Okay, welcome to Unit 1, Lesson 3 on analyzing graphs of functions. In this lesson, we're going to be looking at different aspects of graphs and determining specific information from the graph. So we will look at domain, continuity, intervals of increase and decrease, and then over here on the second page we'll be talking about specified intervals, and then we'll also be evaluating functions. So to begin with, we'll talk about domain. Alright, domain are all the x values of a function that you can use to generate a y value. So when I'm looking at the graph here, I'm going to be looking here on the left hand side first. You read a graph from left to right like you do a word. So here I see an arrow pointing to the left. Arrows that point to the left indicate that the graph will continue to the left forever towards negative infinity. And then I'll just follow that from there and notice that every x value is covered until you get over here to this arrow on the right. An arrow on the right indicates that the graph will continue to the right towards positive infinity forever. So I just put positive infinity there. And this is an interval notation, so we're using parentheses for negative infinity and positive infinity. We look at a second example here. Again, on the left hand side is an arrow. This arrow is pointing up, but it doesn't matter if it's pointing up or pointing down. All that matters is that it exists on the left hand side. On the left hand side, the domain is negative infinity. And then it continues, goes down for a while, then it comes back up, and then it goes back down. Again, none of that matters, just that it's going down on the right hand side. So again, an arrow on the right indicates infinity. It doesn't matter if it's going up, as we have here in the first example, or down in the second example. It's on the right hand side, so it's positive infinity in both cases. So let's take a look here. Now I made a couple modifications on here that is not very clear to see on yours, but you see these are open circles indicating that those values, those x values, do not produce the y value of 2. This is not included. Alright, so when I'm looking at my domain, again on the left is a negative infinity, so again I'll indicate negative infinity. Now I'll follow this along. When I get to here, right, negative 1 gives me a y value of 5. And then it jumps down here to negative 2. However, it's an open circle, but this is a closed circle, so it continues. My domain, there's no gap in the domain, because negative 1 gives me 5, whereas 0 gives me 2, and everything in between is filled in. So I can just continue. I don't need to indicate anything in my domain until I get here to an x value of 5 where it stops. Since it's a closed circle, I'll use a bracket. Now notice there's a gap here, right? Between 5 and 6 there's no x values. So I'll put a little union to indicate that spacing on the x-axis. Whereas this did not have any spacing. They just connect right up to each other. But here there's a gap. So, and 6 has a circle indicating that it's not included. So I'll use a parenthesis to show that it's a circle and not included. And then this continues on from 6 all the way to this arrow on the right indicating positive infinity. So there are the gaps in the domain. Alright, let's talk now about continuity. So continuous or not continuous is basically a yes or no question. If I put my pencil down here and go across the graph, do I ever have to lift it up? Since I don't ever have to lift it up, I would say yes, this is continuous. And for some reason my pencil, there we go. So again, goes down, goes up, comes back down. Never lift the pencil up. So yes, this is continuous across the domain. Now here, I have to lift the pencil up to come down, right? Even though this is a circle, and this is a circle here as before. In the domain, there was no indication here that there was a gap in the domain, but because I pick my pencil up and move it down to here, that's automatically a no. The first time that happens, you can stop and just say no. This is not continuous. Alright? And that's continuity. Just do you have to pick your pencil up or not? Okay, so the next thing we're going to be talking about are interval of increase and decrease. Now this is one of the more difficult topics that we'll cover in the lesson. It just seems to give people a lot of trouble. So we'll try to go through this slowly and with clarity. Alright, so if I'm looking at this first graph here, if I look here at the beginning, notice that this has a negative slope, right? This is a negative slope here. Whereas if I'm looking at this side of the graph, from the vertex up, it is increasing, right? This is a positive slope. So if I want to talk about interval of increasing, I'm looking for a positive slope. Now, it doesn't have to be a slope, it could be a curve, but in general, positive direction, right? Increasing. So the interval of increasing is a part of the domain. So I see that the vertex is located at an x value of -2. Now with intervals of increasing and decreasing, I will always use a parenthesis because at a given point, you can't be increasing or decreasing. That's a movement. It's a type of direction you're going in. Are you going up or are you going down? And so at a given point, you're not doing anything. You're just at a position. So I will always use a parenthesis. If you use a bracket, we're not really going to count off, but if you always use a parenthesis for interval of increasing or interval of decreasing or interval of constant, I think that's going to be most appropriate. So as I see at -2, it starts to increase, and then I see that an arrow over here on the right, so I know it's increasing from -2 to positive infinity. And then the red aspect, right? The red over here, right? It starts at -infinity and goes until -2 when it stops decreasing. So if you look at the whole domain of this, we found was -infinity to positive infinity. When you put these two intervals together, you get -infinity to -2, -2 to infinity. So we've covered the entire domain of this function, and if you look at this, it's going down and then going up, and we've covered everything. So let's look here at the second one, right? We'll start off by, this is going down till you get to this little valley, and then we'll go up. You see, by color coding it, it helps you to see the different aspects, and then from here it goes down again. So what I'm going to do here is go back and talk about the interval of increasing, which is the blue part, and it looks like about 0 is the minimum value, right? The x value is 0, and then it continues to go up until we get to an x value of 2. So from 0 to 2, the function is increasing. And then over here, we see an arrow on the left. So from -infinity, it's going down until I get to the x value of 0. And then it stops going down. Put a little union, because later on it goes down again. See here at the maximum value at 2, it starts to go down again. And over here I see an arrow on the right which indicates positive infinity. So again, my domain, -infinity to 0, it's going down, 0 to 2 is going up, and then from 2 to infinity it's decreasing again. Okay, so let's take a look at the last example we have here, and we'll start here on the left. It's increasing, so I'll make that blue. And then we have a constant here. I'll make that yellow. And then it goes up again. So there's actually no intervals of decreasing at all in this function. So when we go back here, we'll talk about intervals of increasing. We can talk about from negative infinity until negative 1, and then again from 6 to infinity. So those are my two blue sections, because those are the two sections of the graph that have a positive upward motion when read left to right. The yellow section here, again, the yellow section, it's constant because it stays still. It doesn't go up, it doesn't go down. And that starts at negative 1 and goes all the way to 5. So between negative 1 and 5, it's constant. And again, when I put all three of these together, I get the domain negative infinity to 5 and then 6 to infinity, just like we had on the first page. Okay, so let's talk about, on the next page here, some specified intervals. So what I care about here is when f of x is greater than 0. So again, we're going to make that here. They're talking about when y is greater than 0. So these y values are all greater than or equal to 0, and these y values are greater than or equal to 0. Whereas between these 2 points, the y values are below 0. See how they're in the negative? The y values are negative. So those would be the less than zeros. So again, we're going to write this interval. When it's greater than or equal to, we will say from negative infinity until, is that 1, 2, 3, about negative 3. Now, this value, negative 3, if I put negative 3 into the function, I get a y value of 0. 0 can be greater than or equal to 0. Since 0 is equal to 0, negative 3 is included in this interval. So it should have a bracket. And then I'll put a union here. And then it starts up again, bracket, because negative 1 gives me 0. And it goes on forever. So we'll put a infinity symbol here. And for the intervals of less than 0, why don't we try, now see, this would have to be a parenthesis, because again, negative 3 gives me 0, and 0 is not less than 0, so that has to be a parenthesis, and it goes all the way to negative 1. And now I've covered all the parts that are greater than 0 or equal to, and all the parts that are less than 0. Alright, so pause the video, try to do the intervals of increase, or intervals when f of x is less than 0. That got messed up. This should be greater than or equal to 0. Alright, so pause the video and find those intervals and then do the rest, and then we'll come back. So okay, so this should be the answers that you have here. Nothing too tricky here in the first one, right? Just notice that they fit together. Negative infinity to negative 1, negative 1 to 1, 1 to 3, and then 3 to infinity to get the full domain of negative infinity to infinity. And then over here, a little bit tricky. Again, up here, I would use a bracket for negative 1, because negative 1 gives me a y value of 5, and 5 is greater than 0. However, the 6 does not give me a value of 0, because 6 is not in the domain. So that's why the 6 has a parenthesis instead of a bracket. But down here on the red, you see the negative 1. Again, it's not actually a y value that gives me a negative number. That's because the open circle. So that's a parenthesis there going to 5. 5 actually gives me -2, which is less than 0. So that gives me a bracket. So if you have any questions about this last one, we can talk about that in class. Okay, the last thing we want to talk here at the end of the video is talking about evaluating functions. So we did this earlier in the last video with an equation, but now we're given a graph. But it's the same thing. This 1 indicates an x value. So that's my x. If I look over here in the graph, x of 1 gives me a y value of 2. Okay, so let's check out f of 0, right? F of 0 is here. No, my pen's not working properly. Alright, f of 0, here's the x is 0. The f would be 1. And f of 3 gives me a y value of positive 4. Now this says f of x equals 0, meaning y is 0. So if y is 0, that would be, let's just change colors here to make it a little bit easier to see. So here's all the values where y is 0. We have a x value of -3 and an x value of -1. So when it's equal to, multiple x values can give you y values, so just check that. Y of -4 would be down here, and it doesn't appear that there's any x value that will ever give you a value of -4, so you can just mark that with an NA. And let's check 3. Again, here's my y equals 3, or f of x equals 3. And those exist at the x values of -6 and here at 2. Okay, so that's it for the notes. Here's a graph, and we want you to kind of go through all the different things we've talked about today and enter full notation. I want to see you answer all of these questions. Pause the video, answer these 13 questions, and then unpause the video and you'll see the answers and you can check your work. Okay, and here are the answers to the questions 1 through 13. So check through here. If there's anything that you're not sure about or you think may have been a mistake on our part, just bring it to class and we will answer those before we begin, and then you can practice this during class. Alright, hope you enjoyed the video. Have a good day.